Alright, so looking at our next section, which is types of outliers in a linear regression. And let us begin. This is section 3. So outliers. So basically outliers are any points that don't fit within the cloud of the other points, so they kind of are outside of it. So if you get a whole bunch of points, okay, so if you have a whole bunch of points and then you have another point way down here, that would be an outlier. Okay, it doesn't fit with the rest of them. Okay, some of these points are more influential than others, and what we want to do is we want to identify which ones are more influential and see if we can see how much it affects our data. Okay, and sometimes they're so influential that we wouldn't even want to use a regression because they're so influential. Okay, so there are, the first one is that you have like one outlier that is away from everything else. Okay, so if you look at this example, so you have all these points that are all along this line, and then you have this one outlier way down here, and you can see in the residual graph where it is. Okay, this would only be about slightly because there's only one point, it's away from the rest of them. It might pull that line towards it a little bit, but because there's so many points that are already close to that line, it won't have as much of an effect on it. So there is some influence, but it's very small. And we wouldn't worry too much about one like this, okay, based on it. So this is one type of outlier that we have, is that you just have one point kind of out there that doesn't fit, but the rest of the points are on this line. And as you see with your residual, it looks like it all kind of fits there. It looks like it might have pulled it a little bit. Maybe it should have gone up a little bit more, but overall it's not as bad. Okay, so it's only a slight influence. Another one could be that if you have a point that is away from the cloud, but it falls on the line or close to the line anyway. So here you see we have our cloud up on top, and then we have this point, but this point is fairly close to that line, and it looks like that this cloud, it looks like it's linear anyway. So if we did it without this point, it looks like that line would fit that cloud anyway. And this point being close to it looks like it probably has very little influence on it at all because it does fit so close to it. Okay, yes, it is far away from the cloud and everything, but it's close enough to that line that we can go, oh no, it doesn't affect the overall line of it. So it would have a smaller influence, okay, because it's close to that line. Okay, so the next one is away from it, but you see it's farther away from this line. So you see we have that one point, that one outlier way out there, and it's not on the regression line that we have. And if you look at our residual plot, you can see that all the data, this data, looks like it's going down, okay, slightly. It's not following that dotted line perfectly across. This tells us that what's happening is that this point is pulling that line up, and it's having a greater impact on it than we would want it to. Okay, and so that data point is having some sort of impact on this line and having great influence on it, causing problems on our line. Okay, and so that's what we'd have to worry about, is something like this one, where it's basically just pulling that line and making it so that it's more difficult. It doesn't fit the data as well. And if we look at the residual, you can see that it's falling. The group of data looks like it's going down, crossing that data point. Okay. All right, so next thing we could have is another cloud of outliers. So a group, so you see you have like 4 right here that are away from it. And because of that, because now we have multiple points, it's not just one, they're pulling that line again. So you see here, you see that the data is falling again. So it's not, we want it consistent. We want it even number of points above and below all the way across. You see here, this cloud is pulling this line up, which is causing problems again. So if you have a cloud of points, you could also have them create more of a problem with your regression. Okay, so they're more influenced because there's more points. Even though, yes, they are closer to it, there's 4 of them instead of just 1, like in previous examples. Okay, so that whole group is pulling that line. Another one, which this is a real bad one, is that if you have a large difference. So if you look over here, you have that outlier way out there, and then you have this cloud of data. Now, just looking at that cloud of data, does it look like that the regression should be going to that line? Or could you find a line from that regression if you ignored that outlier way out there? And the answer is no. That could be the line. You don't really have enough information. What you'd probably want to do is take those points and spread it out and see. Okay. But because this one point is way out there, it basically takes this cloud, since they're all close together, and then it accounts for that last one, which then swings it upward. I would almost say that that cloud of data probably has a regression line that looks more like this. That is probably more negative with it. Because if you look here at this, you can kind of see more of a negative line going down. And so I would say that it'd probably have more of a negative slope, but because that one point is there, it's taken it and swung the whole thing up. And that has overwhelming amount of sway or power in this regression that that outlier has, which is what we want to try to avoid. So this would be one that we wouldn't do a linear regression on because of that outlier, because the data doesn't help it. It doesn't tell us anything because it doesn't fit what the rest of the data does. So we wouldn't want to do a regression with this one. Okay. So here's another one where you see there's a whole bunch of points on a single line, and then you have that one data point away from it that is also on that line that's fairly close. So you see this one wouldn't have that much. You would be able to do a regression. It doesn't have too much sway, as you see. Even though it's far away from it, it still fits with the rest of the data. It's still within its bounds. Okay, so influential points. So influential points are points that fall horizontally away from the center, and they're also called high leverage points. So these points here would be considered your high leverage points for those. Okay, so some words of warning that you have for these. You don't want to just remove your outliers. So just because you have outliers, you don't just want to go, no, I'm taking these out because they're ruining my data. No, you need a good point, good reason why you're removing them. Okay, and this could be because of multiple different reasons, but if you do remove it and you're doing some sort of study, you want to be able to state why you're removing. You want to mention that there were outliers and mention why they were removed. But for the most part, you don't want to just take out data points because of they don't fit my data. I want my data to do this. That's not correct. That's not how you should use statistics, even though many people do. When dealing with categorical data, just make sure that you have multiple points for each category. You don't want, so like that new and used when we talked about Mario Kart, if you only had one new, you wouldn't want to just use that one new. You'd want to have multiple new and multiple used. Okay, so if you have multiple categories, have multiple points for each category. Because if you only have one or few data points, what ends up happening is that they have more swing, more power, more influence than the rest of them. Okay. All right, that's the end of section 3.